Hi, this is a basic explanation of what it means when you have similar triangles and how to solve using proportions because they're similar triangles. We're not covering the geometry definitions of similar triangles here, however. We're just covering how to handle the proportions when you have similar triangles. So in this situation, we have two triangles, and this is from your discussion question. We have this side is 5, this is 4, this side is not given, this side is S, that's an S, and this side is 6, this side is not given. Now they're set up, we will assume similar triangles. We're not discussing exactly the rules for similar triangles. So the way you set up a proportion is, let's see if I can't. You have to make sure that whatever triangle you start with for setting up the first proportion, that you start with when you set up the second proportion. So in other words, the first proportion, we will start out using the small triangle, and so I will put 5. This side of the small triangle. Now this side corresponds to this side. It doesn't correspond to this side. This side and this side are proportional because they're the same side of a similar triangle. So this side is S. So the first proportion, we started small triangle to large. We got a little small triangle to the large triangle. So that means our next proportion has to be set up. That's a pretty weak L. Has to be set up with the same direction. We start with the number from the small triangle on this side, that's 4. And we put it over because we're going small to large. This bottom corresponds to this bottom, so the 6 on the large triangle. This is an S, remember. It doesn't look like an S. We just use the rules of solving a proportion to solve the problem. So how we do that is it's cross multiplication. You multiply this numerator by this denominator, and then you're going to divide by the number left over, essentially, the number from the other side. That's sort of the shortcut. The long explanation is this side, this numerator and denominator multiplied equals this numerator and this denominator. Alright, so if you were to multiply 5 times 6 and set it equal to this numerator and that denominator multiplied, that equals 4 times S, and you solve for S. What that means is you divide both sides by 4. Since S is multiplied by 4, you have to divide by 4, do the opposite arithmetic to solve for S. So, but you have to do the same thing on both sides of the equal sign. Divide both sides by 4. So what you have is 4 over 4 cancels because 4 over 4 equals 1. So what you're really saying when you say 4 divided by 4s is you're saying 1s. Because 4 over 4 is 1, it becomes 1s. 1 times any number, doesn't matter what this s is, it will always come back to that number. S. For example, if this S was a 2, it'd be 1 times 2 is 2. If this S was a 3, it'd be 1 times 3 is 3. So 1 times S is simply S. So now you have a problem that looks like this. 5 times 6 divided by 4. That's the long way of saying what I said at first, which was multiply this numerator by this denominator, that's this here, and then divide that multiplication by the number left over, because there's 3 numbers and there's a letter. The ones that are diagonal are multiplied. The one number left is divided. That's kind of a faster way to think of it than having to walk through the algebra. Whichever way is more comfortable for you is fine. And of course, once you're at this stage, 5 times 6 divided by 4, that's simply math. You just use your calculator if you don't know your multiplication tables, because you will be allowed a calculator on the test. It would be 30 divided by 4. And of course, 30 divided by 4 is not a number you would know off the top of your head. It's going to come out a decimal. So let's look at that on a calculator. 30 divided by 4 equals 7.5. So S, when we're all said and done here, equals 7.5. This still looks like a 5. Let me write that answer down. So the answer then is S, this side, equals 7.5. Notice there are no units in this example. In the next example, we'll talk about units. Okay, that's all.